Good morning, everyone.
Morning.
So can you see my presentation?
Yes.
Okay. So my name is Kateřina Frončková. I'm from the University of Hradec Králové in the Czech Republic, and I will talk about Kalman filter employment in image processing. The Kalman filter is a tool for estimating the state of a stochastic linear dynamic system using measured data corrupted by noise. The estimate produced by the Kalman filter is statistically optimal in some sense. The principle of the application of the filter is shown in this figure. The filter is named after Rudolf Emil Kalman, a Hungarian mathematician living in the United States, who published it in 1960. The classical Kalman filter works with a model of a stochastic linear dynamic system in discrete time, for example, in this form. It's assumed here that the system has no inputs. The first equation is referred to as a state equation, and it describes the dynamics of the system. The vector xk is an unknown vector of the system state at time step k. The second equation is called measurement equation, and it describes the relationship between the state of the system and measurement z. W and V are random noise processes, and it's assumed that these processes have Gaussian white noise properties. The goal of the Kalman filter is to find an estimate of the state vector at time k, denoted as x hat k, so that this estimate is optimal, for example, in the sense of minimizing the mean square error. The Kalman filter algorithm is recursive. The calculation at the general time k consists of two main steps. The first step is the calculation of the a priori estimate at this time step by substituting the a posteriori estimate from the previous time step into the deterministic part of the state equation of the model. The uncertainty of this estimate is expressed by the a priori error covariance matrix P. In the second step, this estimate is adjusted using the measurement taken at this time step, which results in obtaining the a posteriori estimate. Also, its uncertainty is expressed by the a posteriori error covariance matrix. The Kalman filter and other algorithms based on it, the so-called Kalman filters, are used in various application domains. While one of the most important is the area of localization of moving objects and navigation. I would like to focus on the possibilities of its use in image processing, although this is not its typical application area and it's not so known. Grayscale digital image can be naturally represented by a two-dimensional matrix. Its elements then express the intensity values of individual pixels. Using the Kalman filter in image processing tasks does require to extend the concept of the Kalman filter from random processes to two-dimensional random fields. One of the Kalman filter modifications intended and designed for this purpose is the reduced update Kalman filter published by Woods and Radvan. This algorithm was originally designed to filter noise in images, but later Woods and Engel further developed it and extended it for blurred image restoration. The algorithm is based on the following two-dimensional autoregressive image model state equation, where the notation xij represents a pixel of the ideal image located at the position ij, W denotes system noise corresponding to model inaccuracies, and phi represents the corresponding parameter of the autoregressive model. Corruption of the image by additive measurement noise can be modeled by the following scalar equation, measurement equation, where Z denotes a pixel of the noise image and V is noise incurred usually due to the technical principles of image obtaining. Both W and V possess properties of Gaussian white noise according to the assumptions required by the Kalman filter. Sometimes the image may be degraded in addition to noise also by blurring. The measurement equation has in this case this form where H represents blur of the image caused by, for example, motion or poorly focused camera optics. The already mentioned reduced update Kalman filter can be used to solve both these tasks. This algorithm is based on sequential scanning of the image pixel by pixel, starting at the upper left corner of the image and continuing on a line-by-line basis. At any given moment, the currently processed pixel can be perceived as the present, the pixels already processed as the past, and the upcoming pixels waiting for processing as the future. This approach transforms a two-dimensional problem into a one-dimensional problem, and consequently the classical Kalman filter can be used. The problem, however, is that the state vector, which is made up of individual pixels of an image, takes on a large number of elements, resulting in high computational costs. The reduced update Kalman filter solves the situation by not working always with the whole image, but applying the Kalman filter only to a certain area surrounding the currently processed pixel. Before the actual application of the algorithm, it's first necessary to construct an image model. Image modeling is based on finding the order and parameters of a two-dimensional autoregressive model and estimating the variance of the corresponding noise. Various techniques using, for example, the principle of maximum entropy can be used to determine the order of the model. Also, for estimating model parameters and noise variance, there are various approaches or algorithms such as variance of least squares method, correlation-based methods, or approaches enabling to estimate model parameters simultaneously with image filtering. For a practical demonstration of the reduced update Kalman filter, a photograph of the large square in the city of Hradec Králové was used. In the first experiment, additive Gaussian white noise was added to the photograph, as is shown in the image in the middle, and the amount of noise present in this image expressed using the signal-to-noise ratio is 10.7 decibels. After applying the reduced update Kalman filter, the signal-to-noise ratio rose to 15.3 decibels, so the improvement is 4.6 decibels, as can be seen in the image on the right. In the second experiment, the original photograph was degraded also by blurring caused by motion in the horizontal direction, as the middle image shows, and the result obtained by applying the reduced update Kalman filter is shown in the rightmost image. Thank you for your attention, and if you have any questions, please feel free to ask me.
Would you like to pose a question if possible?
If anyone has any question.
Yeah. I have one question.
Yeah.
Okay. What is your specific future direction related to this work?
I focus my research on Bayesian filters, and also I am interested in image processing, and the use of the Kalman filter in image processing is not very well known. So I decided to write this state-of-the-art survey paper, and also it was the first step for my future research.
Okay, thank you very much for your answer. Do you have any question? I think that we don't have any question.
Okay.
Thank you for your
Thank you.
participation. Thank you too.
Goodbye.
Goodbye. And next, I think Milan Kostak and Alan Alesberger and Anthony Slaby.
Yes, hello, I'm Milan.
Hello.
I'm here. If anyone before me is not available, I can give my presentation now.
Okay, your presentation, migration of artificial neural networks to smart phones.
Yes.
Yes, thank you. We can start if you are okay.
I will just share my screen. So can you see it?
Yes.
Okay, great. So hello everyone. As already said, my name is Milan and I am a doctoral student at the University of Hradec Králové, and I will give you a brief summary of our paper on the topic of migration of artificial neural networks to smartphones. I know that this is nothing new, but the thing is that me and my colleagues, we were missing a good summary regarding current methods for both most prevalent platforms, Android and iOS, and for which platforms we wanted to migrate our current system. So what was our motivation? Why did we want to migrate the ANN? The thing is that ANNs are used in many areas of everyday life, and most people sometimes don't even realize it. You can see a couple of examples over here, and I will point out speech recognition and post-processing of photos taken by smartphones. These devices usually have small lenses, and it is actually software that is mainly making photos so nice. Maybe only a decade ago, when someone wanted to take a good photo, a good lens was needed, because if the information wasn't there, you couldn't make it up anyway. But today it is possible. So the thing is that neural networks and machine learning in general is a powerful way to make these things happen. Then smartphones themselves are everywhere. Some people these days even hardly put their phones out of their hands. In general, they are ubiquitous, they are small, they are connected to the internet, and they have much computational power. And all of this makes them an ideal device for many use cases, which weren't possible, again, just a decade ago, maybe. And then, and Android and iOS both support deployment of trained models, and as it turned out, the migration is quite easy. So the problem we were having is that it's something like this, as you can see on the picture. Our current system works by using a scanner or camera for taking pictures of documents. These images of documents need to be obtained in high resolution in order to make the detection work well. So it takes a lot of time to upload them from these devices to a computer. Then once it's there in the computer, ANN processes the document and the user confirms uploading to cloud storage. And we were thinking that the first step could be improved by employing smartphones. So we did a survey on how Android and iOS platforms solve the problem of migrating existing ANNs. And as I already said, it turned out that it's surprisingly easy. There is TensorFlow Lite for Android and CoreML for iOS. TensorFlow Lite can also be used for iOS. That's quite interesting in my opinion. And these frameworks define formats of models and provide necessary converters, because the mobile platforms don't need to make the models in different ways so they can work on these devices. Then these frameworks define, or they are designed to execute models efficiently, because they need to take into consideration the limitations that the smartphone environments pose. And they both support efficient distribution of the computation workload across available processors, and they take into consideration actual battery consumption and many other things. So for our system, this is the solution we came up to. Migrating the ANN shortened the overall processing time. I didn't mention it here, but it was around 3 times faster, because the scanning was quite slow actually. So at the current solution, one device, its smartphone, is taking the image, and once the image is taken, because it's happening inside one application, the ANN can be applied right away. And then once it's done, it takes only a couple of milliseconds. The user only has to confirm sending to cloud storage. We did testing on different devices, low cost, high end, and there wasn't much difference, which was also quite interesting. So our conclusions are these. The migration itself for us was a big success. Google and Apple both provide tools for easy conversion and deployment of trained ANNs. And we were able to save the overall processing time of our task. And the processing is easier, more straightforward, and therefore less error prone. There was one issue, however. Future research should focus on lowering battery consumption, which is currently very high. Unless the user is connected to a power source, the battery can be dead in like 2 hours or something like that. Depends on the device, of course. And that's all. Thank you for your attention. And if anyone has any questions, I will be happy to address them.
I have one question,
Yes.
if possible.
Yes,
what is your specific future direction related to this work?
Yes. So my research focuses on object detection and using machine learning to do it. And that's why we did this survey, let's say, and we applied it to our system, because myself, I'm doing the ANN part, and my friend, he's focusing on, or my colleague, he's focusing on smartphones and research in that area. So we kind of got together and created this paper and migrated to the system.
Yeah, you are right. I think that you can use your proposed system on different domains, such as different kind of data, isn't it?
Yes. In general, it's possible to migrate basically any artificial neural network. And maybe some cases are not possible, but in general, I think you can migrate anything these days.
Okay. Thank you for your answer.
thank you
Thank
for the
you
question.
for your presentation also. I think that finally Yuzu and Jinyao Yan will be presenting us the work entitled A Hybrid Deep Learning Approach for Systematic Financial Risk Prediction.
Yes, can you hear me?
Yeah, please.
Okay. Can you see the PowerPoint?
Yes.
Okay. Good morning, everyone. I'm very glad to have the opportunity to ICCSA. And my name is Yue Zhou. I come from Communication University of China. Here, what I'd like to report is a hybrid deep learning approach for systematic financial risk prediction. I will introduce the work from three aspects. The first is background and the methodology and the experimental and results. Systematic financial risk is a crucial issue in economic and financial system. International experience shows that the outbreak of systematic financial risk almost always causes every financial crisis. Since the 1970s, BIS has begun to recognize the importance of this and start to identification, monitoring, and measurement the risk. Essentially, systematic financial risk prediction is a multivariate time series problem. Traditional approach can be mainly divided into three categories. In this paper, we develop a predictive approach based on CNN and the bidirectional GRU to form a model of economic and financial data and predict the risk trend. Next, let me introduce the methodology of the proposed model. The first part is risk measurements method based on composed indicator. According to the standard definition of systematic financial risk, we conducted the systematic financial risk indicator. We call it SFRI based on the statistical design method. First, we define a data set, a raw indicator as XT, and we propose a transformation of raw indicator based on their CDF. All the indicators were grouped into different sub-market and get the SFRI for each sub-market. And then we calculate the SFRI of all. The second part, convolution neural network for risk feature extraction. In order to extract feature of economic and financial data quickly and accurately, we put forward to use 1D convolution neural network as a local feature extractor in this paper. And the third part is bidirectional GRU risk time series prediction. As is known to all, the GRU model only have a forward path, and each node will only be affected by the previous one. Nevertheless, for the financial time series prediction task, the feature of rural node will also be used for the front one. Based on the GRU model, we employ a BI-GRU network, which composed by two ordinary GRU and process the input sequence from two directions of the time series, and then merge their representations. And this is the overall framework of the proposed model. And you can see it's divided into four major parts. Next, I will introduce the detailed steps of our experimental. The experimental data set used for this paper is financial time series data of China from the first trading date of 2016 and end of March 2019. All data samples are from 11 departments of Chinese government. Consider the economic and financial situation of development countries, especially China. We selected 36 indicators of SFI, and we use MAE, RMSE, and so on as performance evaluation metrics. The proposed model was trained on Keras framework, and here I show some experimental configurations. In the CNN part, it contains two convolution layers with activation function of value, and each layer have a 120 convolution filter. In the BIGIU part, the number of deep learning neurons set to value we choose from a candidate set, like this table, and then we choose 60 neurons. These experimental results, we built several well-known deep learning methods for competitive experiments, including LSTM, stacked LSTM, and BIGIU. The figure shows the single-step predictive value of SFI from the comparer model. And this table shows the result. Generally, this result summarizes that the proposed model achieves obvious superiority in terms of its performance compared with the baseline model. For example, the SMAPE value of the proposed model is higher than this baseline model. And then we design experimental to test multi-step prediction. From the results, we can see that the prediction error of all methods grew as the horizon increases. It indicates that the proposed model is superior to others at all time horizon and achieve relative equality of higher prediction with numerous stability for long-term prediction. And this is my presentation. Thank you all.
Thank you for your presentation. Any question? Would like to pose a question if possible. What sort of benefits did your approach provide in your work?
Sorry?
I have one question, if possible. Okay. What sort of benefits did your approach provide in your work?
Benefits for your our works, right?
Yes. Regarding your work. What sort of benefits?
Kind of benefits. Yeah. Let me see. To verify the performance in this paper, we can see the proposed model can achieve better performance of the baseline model, especially in the trained prediction. And I think we can contract SFI is a good model for financial risk prediction.
Your proposed method, I think that you can use other data set, and is it okay? And you can get again superiority.
Yeah, in the future we will aim to verify the proposed model in other different countries and regions. And now we have to try this.
Okay. Thank you very much for your detailed response. Any question? Okay, we would like to thank you very much for your presentation, and I apologize from those people invited to the meeting but who can't attend. That brings us to end of our session. Thank you very much for your participation.
Carlos Morales is not here. He didn't the presentation.
Yeah, okay. Innovation technology and user experience in museums, insight from scientific literature, isn't it?
Yes.
Okay, can we start it, please?
I don't know if he's here or if...
We cannot see your presentation now.
No, I am Federico, the assistant.
Yes.
Okay, but I'm asking if in this room there is Carlos.
No, I think that he is not coming. So one participant still absent.
Okay, see, if he's absent, we can close this session.
Okay, okay. Thank you, thank
Okay.
you.
Thank you.
Thank you. See you.
See you. Okay.
I mean, we have the barrier of the sea, even if you have the best transportation.
Hello.
Hello,
I am Iris Karaca.
I am Guilherme.
I'm very nice to meet you.
Nice to meet you too.
Thank you. I think that we have 4 participants.
Yes,
Yeah. One of them, I think that Tantani Mavella. First presentation, yes.
yes.
Okay.
I am one of the speakers today.
Okay. Your presentation, which one?
Is the second one, synchronization analysis in models of coupled oscillators.
Okay. Fabricio.
Yes,
Or, yeah, okay.
I am. Yes, is one of the authors.
Okay. We are waiting, first of all, first author, and then
Sorry.
we should wait first author, first presentation.
Yes, yes.
Then, yes, next you can start.
Okay.
Okay.
Good morning, dear colleagues. I'm Vladimir Solovyev from Moscow.
Good morning.
Good morning.
Before starting the delivery of your presentations, let me gently remind you that your presentation duration is 8 minutes and 2 minutes will be allocated for question and answer session. I think that we can start. First of all, welcome. Thank you for your participation. And now we may start with the first presentation. The title of the work is Ambient Intelligent Systems for the Elderly, a Privacy Perspective, and it's going to be presented by Tandani Mavella. Can we start? I think that he is not there and he is absent, I think. Maybe we can continue. Next, I would like to give the floor to Fabricio Breve for the presentation of the study entitled Synchronization Analysis in Models of Coupled Oscillators. Can we start, please?
Yes, we can.
Yeah, okay.
It's appearing the screen.
Yes.
Oh, okay. I will begin then. Good morning. I will present the work that I and Fabrice Breve has begun. The name is Synchronization Analysis in Models of Coupled Oscillators. There is the summary, introduction. I will talk about phase synchronization, the methodology used, the results, and conclusions. Yeah. So visual attention is a technique used by biological neural network systems developed to reduce the large amount of visual information that it's received by natural sensors. So in 1981, Malsberg suggested that each object is represented by the temporal correlation of neural firing activities, which can be described by dynamic models. So a natural way for representing the coding of the temporal correlation is to use synchronization between these oscillators. So the objective of the study is to synchronize some dynamical models based on biological neurons models, which exhibit chaotic behaviors, as was done with oscillators in Breve work. The motivation is to use this synchronized method for visual selection, which the objects represents synchronized neurons, while the rest of the image is unsynchronized. So the phase synchronization. The phase synchronization of two oscillators, P and Q, happens when their phase difference is kept below a certain phase threshold. So as t goes to infinity, the phase difference maintains in below this threshold. The phase I at time ty is calculated as this equation, where k is the number of neural activities prior to time ty, and tk plus 1 and is the time when will occur the next neuron fire. And Tk is the time when occurred the last neuroactivity. So that two oscillators can synchronize with each other, a coupling term is added to the dynamical system as the following. So here we have the states xj and of two oscillators P and Q. The fj is the function that of the behavior of this state. X and mu are the vectors of state and parameters. And this term k times delta pq is the coupling term, where delta pq is the difference between the states. It's a linear coupling, and k is a force, is a coupling force. So the proposed models for the attention system are a two-dimensional network of neural models dynamical systems that represent an image with a couple terms. The dynamical systems used were the Hodgkin-Huxley, Hindmarsh-Rose, integrate and fire, spike response model, and it was used the fourth order Runge-Kutta numerical method. And the discrete models were used either as the IHARAS model, Rokov's, Izikevich, and Kurbage, Nekork, and Vedov. And it was so firstly, we search for chaos by varying the parameters values, and if the chaos wasn't found, we added some white noise. So the first thing, we coupled two oscillators, and then we tried to see if the models could couple in a vector, and then finally in a grid of oscillators. Then, if the models synchronized in all the others conditions, we try to couple some of the oscillators and unsynchronize it in respect to others. So if we could synchronize the neurons that represents pixels in an image and synchronize the rest. That is, it's not of our interest. So the results, the Hodgkin-Huxley, we used some white noises, so that can represent different oscillators, and Hindmarsh-Rose represent chaotic behavior. Integrating fire, which is a linear differential equation, we have to use stochastic terms. Spike response model, it's a linear differential equation, but actually we can integrate the model. So I used another term that is the term limit, which is the time when arrives stimulus from presynaptic neurons. So if the time is different, then they do not synchronize. And we'll see later that the SRIM has different behaviors of a coupling. IHARA is a chaotic model, so justifying the parameters could create chaos. Rokov is also chaotic. It has bursting behavior. Izikevich, we could find chaos either, and Kurbage, Nikov, and Vidov, and the CNV model, we could find chaos. So we try to see if the difference between the voltage and the phases we could find it could synchronize either complete if the voltage difference is 0, or phase synchronization by looking the phases. So for the Hodgkin-Huxley model, the trajectories difference didn't show complete synchronization. It has some variations. And for the phases different, it's below some threshold, which we set at 2 pi. For the Hindmarsh rows, the trajectories difference didn't synchronize completely either, but the phases difference show synchronization, as much as for integrating fire model. The trajectories difference didn't show complete synchronization, but the phases showed. For the spike response model, as I said before, with the limit value, which is the time when the spike from pre-neurons arrive, if the values are equal, then they synchronize, as in the oscillators 0, 1, and 2. But in 3, 4, 5, 6, 7, and 8, the values were different in respect to the first one, so they didn't synchronize. For the tragic difference, they didn't synchronize in either way. So for the IHARAS model, the trajectories difference didn't synchronize, neither the phases. And as much for Rukovs, that didn't have a phase synchronization. So for Izikevich and Kurbage-Nikork and the dog. So for those models tested, trajectories and the phase difference of the models Hodgkin-Huxley, Hindmarsh-Rose, and integrated fire in agreed with synchronization and unsynchronization oscillators. So here we have the trajectories. Some of them are synchronized, and another ones are not, as we can see here. We have 6 oscillators that are synchronized, and 3 of them aren't. As much as for the Hindmarsh rows, we have some trajectories that are synchronized and another ones that have different behaviors, and they are not synchronized. As we hear an explosion of the phases here, the phases difference. And some oscillators are synchronized in phase. So for integrating fire model, here we have some synchronized and another ones are not synchronized. And here we can see by the phases difference. There are the explosion of the phase difference, while the other ones maintain in a certain phase. So conclusions: discrete time models didn't synchronize, while the continuous time models synchronize. Spike response models synchronizes without a coupling force, only considered the arrival time of presynaptic stimuli, but did not show any chaos behavior. And the continuous models tested for the synchronization and desynchronization for a cluster formation depending on the coupling force showed a potential solution for a visual selection mechanism for an attention system. And these are the bibliography. And that's it.
Thank you for your presentation. Any question? Any question? Would like to pose a question if possible.
Yes.
what sort of benefits did your approach or system provide in your work?
Yeah, we actually we try to simulate how we can create an attention system, visual selection, based on the neuron models, mathematical neural models. So we could we would like to have a how the word I try to find the word, the most closest possible to a biological system using the neurons models. And it can find the you can see how which object is selected by the trajectories. If you could plot the neurons activity, some of them are very you can see the synchronized, and the other ones they are totally random distributed in time.
Okay. What is your specific future direction related to this work?
Sorry?
What is your specific future direction related to this work?
Which one I base it?
Yes.
Yeah, I base it at the Doctor Who. I think it's Doctor Who work of my academic advisor, Fabrizio Greff, which is the bibliography. I think is the 31. He used that, but with the which was the Lorentz, I think, oscillator. So we tried to use it based on neurons models.
Okay. Okay, thank you very much for your answer and also your participation.
Thank you.
Next, I think that Bonaventure Molok Wu, Shahon Bath, and Hashova, Narayan Sikar, and Ziad Kopti will be presenting us to the work entitled Classification of Actors in Social Networks using RLVECO. Can we start? Okay, I think that we can move next presentation. Finally, Anna Kuznetsova, Tatiana Malova, and Vladimir Soloviev will be presenting us to the work entitled Detecting Apples in Orchids using YOLO V3. Okay.
Good morning, dear colleagues. I'm Vladimir Soloviev from Moscow, Russia. Do you see my screen share?
Yes, yes, we can see.
So we are developing a robot to pick apples in orchards, and I'm going to discuss the machine vision system of this robot using YOLO V3 that we applied to detect apples. And I will start with, just one second, with inevitability of agriculture robotization, because manual labor is still the main component of cost in agriculture. the level of automation is extremely low. It is about 15%. The fruits are harvesting manually, and crop shortages reach 50%. So fruit picking robots have been developing since the late 1960s. It's about 50 prototypes of apple harvesting robots up to date, but not a single prototype has entered the phase of practical use in real orchards. Of course, these robots are extremely expensive. The fruit harvesting speed is extremely low, and the share of unhandled apples is very high. Different approaches were used to detect apples, to detect fruits on trees based on color, shape, texture. Machine learning systems have been used to detect fruits since the late 1970s, but only deep neural networks became the promising approach to successfully detect fruits on trees. Many neural network models have been trained to recognize apples like YOLO, RCNN, DASNet, and many special models for apple detection were developed like YOLO V3 Dense, LedNet, etc. But there are a lot of problems preventing these models to efficiently detect apples. So we propose not to develop a special neural network for apple detection, but to use the standard YOLO V3 algorithm with special pre- and post-processing of images. In our apple harvesting robot, we have two cameras on the platform and one camera on the manipulator. We use the standard YOLO V3 algorithm and special pre- and post-processing procedures to detect apples, and then we use inverse kinematics corrected for wind and other noise in order to pick apples. We prepared a test data set of images taken from industrial plantation of the apple orchard during the last harvesting season. In Russia, we used different pixel resolutions, we used different distances for shooting, and there are images taken in different lighting conditions, in sunny and cloudy weather, with front lighting, side lighting, back lighting, and scattered lighting. So the whole data set contains about 900 images with more than 5,000 ripe apples of different varieties, including red apples and green apples. Among them, there are 5,500 FabView canopy images with about 4,500 apples and 274 close-up images with 533 apples in total. First of all, we use this standard YOLO V3 without pre- and post-processing, and the results were not very good. You can see the recall or fruit detection rate is just 9.1%. Only 9% of fruits were detected, and about 90% were not detected. So it's impossible to use such an algorithm. For some reason, I think the presentation is not showing. Just one sec. Yeah, it shows now. For some reason, sorry. And these results show that we couldn't use just standard YOLO V3 without pre- and post-processing to detect apples, because it just couldn't detect real apples on real images. The main factors preventing apple recognition in images are shadows, glare, overlapping leaves, backlight, dark spots on apples, empty gaps between apples, between the leaves, mistaken for small apples, proximities of the green apple shade to leaves shade, and overlapping apples by other apples, branches, and leaves. First of all, we started with first stage of preprocessing, including contrast increasing, slight blur, and thickening of the borders. And it helped us to detect apples with shadows, glare, and overlapping leaves. On the left side, you can see the images without preprocessing with apples that were not detected, and on the right side, preprocessing just helped to detect apples in these images. The first stage of preprocessing included identifying images with backlight by the prevailing average number of dark pixels and strongly lightening of these images. And you can see that it helps to detect apples in images with backlight. The third stage of preprocessing included identifying spots on apples, perianth, and thin branches as brown pixels and replacing these pixels by yellow ones. And now we can detect apples with spots and thin branches, and it was quite good. Then we applied YOLO V3, and after applying, we used some post-processing. We identified yellow leaves as objects whose ratio with greater side.
Non è che è un'offesa, cioè nemmeno l'articolo c'è nel programma e nessuno se ne fotte. Abbiamo detto che lo presentavate, che qualcuno andava a vedere che giorni siamo.
Excuse me, could you just...
I muted him, sorry.
No, what is the problem? I don't know.
You can proceed, sorry, I muted him.
Okay, we can continue, please.
So the post-processing included identifying yellow leaves as objects whose ratio of the greater side of the circumscribed rectangle to the smaller one is more than 3. Identifying gaps between the leaves as small objects whose area of the circumscribed rectangle was less than the threshold, and we discarded just these objects. As the results, we can now detect yellow leaves and gaps as background, not apples. And finally, the standard YOLO V3 with our pre- and post-processing procedures could successfully detect red apples, could successfully detect green apples. And the last thing we've done for far-view canopy images, we divided the whole image into 9 regions, and it helped to successfully detect apples when there are a lot of apples on trees, like 50 apples or 70 apples on one image. So finally, with our pre- and post-processing procedures, we have now a recall or fraud detection rate, not 9%, but 90.8% in the whole set of images. And in far view canopy images, it's 93.3% fraud detection rate. In close-up images, it's a bit less, 83%. 83.7%, sorry. The false positive rate, which means objects that are detected, that are marked as apples by the algorithm, but they are not apples in ground truth, is like 7.8%. In comparison, sorry, you can see the precision recall curve here, which looks quite good. And in comparison with other algorithms, we have better results on in terms of recall for the whole data set and for far view canopy images, and comparable results in terms of recall in close-up images. By the way, the test data set we used is the largest data set in comparison to all the other recent works, because they used 150 images, 480 images, and 560 images in different papers, while we used 878 images. We tried to detect oranges, which works quite good as well, and we tried to detect tomatoes, which works unsatisfactory, but we understand how to retrain the network in order to successfully detect tomatoes. So that's all, and I will be happy to answer your questions. Thank you very much for your attention.
Thank you very much for your presentation. Any question? Okay. Would like to pose a question if possible?
Yes, please.
Okay. What sort of benefits did your approach provide in your work?
So we are developing an apple harvesting robot, and we want this robot to successfully pick apples from trees. It's just a practical application, and we want to use this apple harvesting robots in real orchards. We want the horticulturals to use this robot. And in this case, the fruit detection algorithm should be efficient enough. Because manual harvesting means that like 40 to 50% of apples remains on trees, and if we will pick more than 70% of apples, it will be quite good.
Very good accuracy rate, really very good. It's interesting. Great presentation, also great work. We would like to thank you very much for your dedicated works and your presentations. I think that some people didn't join and apologize from those people invited to the meeting, but who can't attend. That's all for session. Thanks a lot.
Thank you.
Thank you too. Any question, or we can?
Okay,
close
I
it.
just ask you to remember to fill the form for evaluation of the paper. Okay.
Okay. Thank you very much. See you.
Thank you. See you.
Bye bye.
Bye bye.
Thank you very much, and see you. Bye.
Bye bye.
Hello?
Hello.
Hello, can you hear me?
Excuse me?
Hello, can you hear me?
Yes, tell me.
Good. Okay, we are ready to start the session.
Okay.
In few minutes. I'm Alfredo Guzzocrea, I will chair this session.
Okay.
So you know the time for each one, more or less?
8 minutes for
Yes.
presentation and 2 minutes for question.
Okay. For a moment. Okay. I will start this session. The first presentation is on complex network construction. And the speaker is, or is the name of the speaker?
I am the speaker, Fabrizio Brevi.
Okay, Fabrice. Okay, please go.
Thank you.
Are you sharing the slide?
Yeah.
Good.
Just a moment, please.
Yes. Oh, good.
Okay, so I'm Fabrizio. I'll present this paper, Complex Network Construction for Interactive Image Segmentation using Particle Competition and Cooperation, a new approach. So, in a nutshell, the particle competition and cooperation is a semi-supervised learning method where we get the data set and we convert it in a non-weighted and non-orientated graph like this one. So each data item corresponds to a node of the graph, and the edges are generated among nodes that have some similarity relation between the data items. Usually we use the Euclidean distance for this. Then we create particles corresponding to the labeled data. So the nodes that are labeled, that are previously labeled, we put a particle on it. And then these particles will walk through the graph and they will try to dominate as many nodes as possible. For instance, this is the yellow class and this is the red class. Particles which belong to the same class, they cooperate, and particles that belong to different classes, they compete against each other. So in the end of the iterative process, we will have all these nodes labeled by one of the classes, and we can have as many classes as we need. So when the PCC method is applied to interactive image segmentation, we have each pixel converted into a node, a graph node. And for each pixel that is labeled by the user, let's suppose this is the image to be segmented, and that the user put some labels here on the background and some labels on the foreground. And then we have the graph built. So each pixel becomes a node, and each labeled pixel also becomes a particle. And then the particle competition and cooperation process takes place. And at the end of the iterations, we will have the image segmented. And the features that we use to build the graph are features from the image, like RGB and HSV components, and the pixel localization. So in the previous approach, we have to use a weight vector that emphasizes which of the features that we want to have a higher weight. And that depends on the image to be segmented. So it requires some expertise from the user. In some cases, pixel location is more important. In other cases, RGB components, one of the RGB components can be more important. And this affects the network construction, and it has a big impact on the segmentation accuracy. So some methods to automatically define the weight vectors were proposed, but they had limited success. For instance, some they work in some images but fail on others, or they use an optimization process to define the weights, but the optimization process is time consuming and takes more time than the segmentation itself. So in this new approach, we are proposing the elimination of this weight vector through 4 new behaviors. Like we have a different set of features, a new form of user annotation, a new approach to define the edges among network nodes, and the particle influence is measured before the competition process starts. So it makes the process a little easier. So this is the new set of features. We use the pixel location components. There are 10 features in total. Pixel components, line and column, the RGB components, only the V from HSV system, because hue and saturation is not really meaningful in segmentation, so use only the intensity. The color components XR, XG, and XB that can be generated from RGB. And a new feature which is extracted from the auto binarization algorithm. So here we have an example of this, except for the pixel location, all the 8 components are here. So these are the features of the new method. Here we have the new form of user annotation. So before we had only the scribbles, but now we have also a cut polygon that the user can draw here to minimize the amount of that. Regarding the edge among network nodes, in the reference model we connect each node to k nearest neighbors, considering the Euclidean distance, and k has to be set by the user for each image. In the proposed model, k is fixed, and each node is connected to 192 nearest neighbors, and there are another 8 connections made in a 3x3 window with the nearing neighbors. So we have a total of 200 nearest neighbors and 200 neighbors, and this is a fixed number. The user doesn't have to set it anymore. Regarding particle influence on the network, now we have an influence set by the label nodes in the other nodes before the iteration process starts to make the process easier later. So nodes that are 1 hop away from a label node, they get a 0.2 increment, and the others that are 2 hops away, 0.1 increment. The experiments were performed on 151 real-world images taken from the graphical dataset, Pascal Vox dataset, and alpha mating dataset. And they were to evaluate both models. The weight vector on the original model is set so all the features have the same weight. And the marking, the labels, were defined for the tests, and the cut polygons are available on GitHub. Each image were evaluated 3 times, and we took an average because the method is stochastic, so we had to take an average to get a better estimation. Here, 5 images that we did not use the cut polygon histors because the image was taking almost the full image. The object of interest was taking almost the full image, and even then, the proposed method was considerably better than the reference model. in all these 5 images. We have some of them here. So the red here represents the pixels that were wrongly labeled, and the reference model had a higher error rate. And visually, we can see that there are many mistakes here, but there are fewer mistakes in the proposed model. The same thing on this other image. It's much better on the proposed model than the reference model. Here too, more errors in the reference model. This one was good in the reference model, but it was improved as well by the proposed model. And these two also highly improved by the proposed model. Here are the error rates in the image with the lowest error rates among those 151 labeled by the proposed method. And here we have really low error rate. Here too, we have lowered the error rate a lot. Here we have many red dots here, but a lot fewer red dots here in the proposed model. This is one of the highest improvements. Here too, big improvement. There are many red dots here, but only a few here. And here too. Also, good improvement by the proposed model. So, the generated characteristics of the new model are these, like the reference model generates much more particles and much more nodes, and consequently much more edges than the proposed model. So we have we reduce the amount of particles, nodes, and edges, and this, of course, contributes to the lower execution time of the proposed method. So not only this is the average error rate for all the images. So the reference model had a 3% error rate, but the proposed model has only 0.5% error rate. And the execution time is also much lower, less than half, because of these simpler complex networks. And here the relation analysis between the error rate and the processing time. In blue, we have the images classified by the proposed methods. So they are all concentrated in this area here. So lower time and lower error rate, while the reference model is much more spread. We have some images with good error rate and relatively fast time, but many of them are in this area with longer processing time and the higher error rates. So in conclusion, this paper presents a methodology to improve the automation level, improve the accuracy and the performance of the particle competition method when it's applied for image segmentation, interactive image segmentation. And we achieved this by the elimination of the weight factor, which was a parameter to be set by the user, which required expertise. We optimized the network construction phase. We didn't change anything on the particle competition and cooperation steps, so we only changed the network construction phase. The average error rate decreased a lot from 3.13 to 0.49, and we got faster processing. We got more than half of the time took by the reference model. So this, thank you for your attention.
Okay, we thank the speaker. Any question to this talk? I have a question. I was curious to understand if you analyze how every component in your programs influence each other.
You mean the features?
Yes, yes.
Yes, actually there are some redundancy, like HSV and XRXB and XG are taken from the RGB values. But we did some simulations with different features and trying to select the best features, and we find out that even though there is some redundancy, it contributes to a better accuracy of the segmentation process. So these features were selected because they provide the better accuracy.
Okay, there is a question by Veronica. Please go ahead.
Hello. You said that the algorithm is set on the number of neighbors 200. And my question is, is it optimal for every type of objects in an image? Well, I mean, does it work for small objects as well? Because most of these objects you have shown were quite big in the image.
Okay. This number, these 200 connections by each node is a kind of a compromise. It works for most. It works fairly well for most of the images, but of course we could still improve the accuracy if we set a proper value for each image. So I don't think the size of the object will influence the most, but there are some cases that a different number could improve the classification accuracy a little. But we try to avoid that the user has to set this value because it's not very intuitive. It's difficult to find the best value for each image. So we tried to find the value that would work for most images and just fix that.
Okay, thank you.
Okay, we go to the other presentation with thanks the previous speaker. And then the other presentation is on convolutional neural network, and the speaker is
Giovanni.
Giovanni. Okay, go ahead.
Let me share the screen. You can see the share. Can you see the share? Sorry.
Yes, we see Giovanni.
Okay, let me.
Okay, go ahead.
Good morning, everyone. I'm Giovanni Caluña from Yechay Tech University in Ecuador. I'm going to expose our work, which is called Convolutional Neural Networks for Automatic Classification of Disease Leaves, the Impact of Dataset Size and Fine-Tune. This presentation has this outline, the motivation of this work, an introduction, the contribution, the methodology, results, and finally conclusions. We start with that all the countries has large crops, and usually these crops needs to be human controlling to prevent from disease, plague, etc. And it is translated to time-consuming, inefficient, and expensive task. Currently, there exists automatic approach, which the main purpose is to identify disease at the initial phase and decrease the huge effort of humans. This stage, this approach has a stage as image acquisition, which is get the image to be analyzed, the image preprocessing, which is enhance the quantity and the quality of our image, the future extraction, which is get the most relevant features from our image in order to train our the models, and finally the classification, classify an image depending of the characteristics of that image. The most common computational techniques is the CNN or convolutional neural networks. The most common used in this kind of work in agriculture are the CAFENet, AlexNet, GoogleNet, BGG, ResNet, Inception B3, which were used in single and multiple crops as tomato, pear, and more examples. The most common problems for in this kind of techniques, it's the number of parameters managed by the architecture, the computational cost, the training time, and for another hand, we have the size and the variety of the dataset used to train the models. The contribution of this work is select, implement, adjust, and compare the most substantive deep learning techniques. In this work, the convolutional neural networks for live disease classification. Create an appropriate dataset for training and evaluation purpose and handle common problems such as the overfitting. Evaluate and measure the influence of the hyperparameters in the training and deployment phase. The methodology of this work is divided in 3 different experiments. In the first one, we have the 5. In the first one, we use the raw dataset, the original dataset extracted from the source, and we trained 5 optimal models that we found. In the second experiment, we create different datasets with data preprocessing techniques, and we train 1 model with that dataset. And finally, in the experiment 3, we define and fine-tune the most relevant hyperparameters of each model. Here we have the models. We divided in 3 subsets. The first one called GoogleNet and Inception B3, which has the Inception models, a model which helps to decrease the number of parameters. The second subset is called ResNet 50 and ResNet 101. These models use a residual model which helps to avoid the overfitting. And finally, the CFNet, the simple model in this work, which doesn't use any kind of model, just convolutional layers. In this table, we can see the pros and cons for each model. As we can see, as example, CFNet just has 8 dips of layer.
We are not hearing anymore. We are
Sorry?
not hearing anymore.
I don't understand, sorry.
Can you check your microphone?
Here,
We are
you
not
can hear
hearing anymore.
Let me a second, please.
I can listen.
I can listen too.
Me too. It's not my problem. It's not here.
No, I don't think it's your problem.
So?
Yes, we can hear you.
I think you can proceed with the presentation. And maybe the chair can task every one of us. I don't know.
Okay, in this table we can see the pros and cons for each model. As we, for example, we have CFNet with just 8 dips of eight layers of dip, and Inception B3, for another hand, has 159 dip of layers. The dataset used in this work was extracted from Kaggle. It contains 13,000 images with 26 anomalies from 14 crops, which are divided in healthy and unhealthy leaves. As we can see some examples. In order to create a different dataset, first we create one dataset and control variation in order to hide and highlight different features from of dataset. After we create another dataset with the common technique called data augmentation, where from the original image we apply different techniques to create more image, applying zoom, rotation, and different operations. Finally, we add random classes. We add these random classes in order to increase the variation among the classes of our dataset. Now we have the results that we obtained from the 3 experiments. In the first one, we obtaining 91% in the CFNet, 84% with GoogleNet, 83% with Inception v3, and in ResNet 101, we can see that obtaining just 52, which reflects an over 50 produced by the deeper of the model and the poor variation of our dataset. By this reason, we select this model to apply the different dataset that we create. Here we have the results with the different datasets. With the first one, illumination change, or the brightness and contrast variation. B, with the data augmentation. C, the random classes addition. And in D, we create a bigger dataset with all the techniques mentioned before. And we see the results that A just increase the over 15 because we can add useful information. In the case of B, with data augmentation, we increase the accuracy, but in less extent. In the case of C, when we add random classes, but we add variation, but not useful information, the accuracy decrease. But when we increase the variation and increase the useful information, we can increase the accuracy in 50%, as we can see. Finally, in the fine-tune experiment, we define the most relevant hyperparameters, in this case, the learning rate, step, and maximum number of iterations, and we select a range of the most possible optimal values. We have 6, and we perform 6 tests for each model, and we obtain different results. As we can see, there is a big variation depending on the hyperparameter. GoogleNet, we have an 87%, Inception v3 at 77% as the best results obtained. In ResNet 50, we have the worst performance. And ResNet 101, 86% with the fine-tune. CFNet with a 93%, the most optimal value in this work. As conclusion, we have that preprocessing techniques increase the performance of a CNN, a convolutional neural network, especially in dataset where the quantity and quality are limited. We establish the optimal hyperparameters for a model, which has a big relevance for the performance. And finally, we establish the CFNet model as the most appropriate to develop a lived image classifier. I would like to thank to the public company Siembra in Ecuador, which give us access to the supercomputer Kinde-1 to train all the models. That is all. Thank you very much.
Thank you for your presentation. I don't know if the chair is here. Are you here, Alfredo Puzzocrea? Okay, I think he's not here. So, there are any questions? Veronica?
Yeah, hello. It's just a question
Hello, I
out of
can hear
curiosity.
you. I can
Hello?
hear you. Yes,
What?
I can hear you.
I don't understand.
Alfredo, can you hear us?
Federico, you can do the chair instead of me?
Yes.
No, I'm joking. I'm hearing you. Please let me to say.
Okay.
Thank you. Is there any question?
Yeah, I've got one.
Okay.
It's just out of curiosity, because I work with CNNs too, and my question is, did you consider to test convolutional neural network with UNet architecture in your work?
Sorry, I don't understand the last part. Consider?
Did you consider to test UNet architecture for convolutional neural network as well? Because we saw some types of architectures, and UNet is a different one. So my question is, did you consider to test it?
We perform a review from all the most common or the most relevant, but the most optimal for this work was the ones that we select because of the parameters that we establish. We are working for low number of parameters, a low number of operations, and that was the criteria that we used to select because we know that there is a lot of CNN architecture which has different use and different fields.
Okay, thank you.
Any more question? No, okay, we thank the speaker and we go to the other, if even the extra chair agree. If is okay, I can introduce the next one. His name is Giovanni. He will present us a paper on a kinetic-based acquisition reproduction system for robots. Okay, go ahead, Giovanni.
Thank you. I am with the ICCSA Italian National. Sorry. Hello everybody, my name is Giovanni Pilato. I am with the ICCSA Italian National Research Council, and today's talk will be about the Kinect-based gesture acquisition and reproduction system for humanoid robots. The work has been conducted in cooperation with the IDEA Lab of the University of Calabria and the University of Palermo. The aim of the work is the implementation of a system, first implementation of a system for a pepper robot capable to acquire and reproduce the gestures performed by a human user during an interactive session with the robot. In particular, we exploited a Microsoft Kinect sensor to capture the motion data from a user. Since the user has different possibilities of making a gesture, and the hardware of the robot does not reflect the body of a human user, we defined the mapping algorithm to allow the SoftBank pepper to reproduce the tracked gestures as close as possible to the original ones performed by the user. Here we can see the system at a glance. We have the Kinect, then 3 modules, the viewer, the gesture brain, and the pepper DCM that allow to to catch the positions of the human, the gestures of the human, and to reproduce or store them in a pepper robot. From the Kinect, we get the Cartesian coordinates for each joint, the quaternion for each segment, and the reliability value for both are extracted. The bridge pepper DCM uses Euler angles to communicate to the robot the new position of its joint angles. The viewer module extracts data frames from the Kinect and sends them in a pipe. The module also provides the feed of the Kinect camera with the overlay of the tracked user's skeleton. The pipe is then read by the second module, which is the gesture brain. The gesture brain works both as a gateway for the robotic operating system and as the module where the actual data processing takes place. The gathered data cannot be used directly, as I said before, because of this, mapping is required to correctly associate each joint of the user position to the equivalent one in the Pepper robot. In our algorithm, we decided to use only the coordinates of the joints. We assume that the joint data is accurate enough for our purposes, as the Kinect already discards joints whose reliability values are too low. We exploit the Pepper DCM to send the joint angles to the robot, and the threads consist of multiple joint angles divided into two groups, and each group is representing a body part. In particular, we use the head, left arm, and right arm. The bridge dynamically calculates the gesture trajectory in real time, and it was modified by us to activate the built-in self-collision avoidance and to deactivate wait and breathe animations of the Pepper. The Kinect joint detection is based on the shape of the user, and noise can happen, and it can be classified in a constant Gaussian noise or large spikes when the Kinect fails to guess the position of one or more joints. A simple manner to compensate part of this noise is to use a line of best fit, and the result is a smoother movement, especially when Kinect is not able to detect the precise coordinates of a given joint. The robot the system can be used in three modalities: Mode 0, which is mimic mode, Mode 1, which is pose mode, and Mode 2, which is playback mode. In Mode 0, which is the default mode, the system makes the robot mimic the movements of the user. If the mirror flag is active, every movement is mirrored. It's just a feature that we have used. In Pose 1, we have that the robot executes a pose that the user should try to emulate. We have used the distance algorithm that computes how the the user has executed the gesture correctly or not. And in Mode 2, we have playback mode that simply consists of reproducing a previously recorded gesture. If we have a mirror flag selected, it is ignored completely. The mirroring was introduced to let the robot ask the user to act as a mirror. We have also implemented three auxiliary algorithms: the distant measurement, the mirroring, and the recording in playback. So we have realized a preliminary system capable of detecting the user poses with the Kinect with sufficient accuracy. This is confirmed by the first experiments that show that the reproduced movements are precise and smooth, the mirroring is accurate, the pose evaluation is coherent. Furthermore, the recording and the execution of the gestures are very close to real-time movements. Currently, we are setting up two experiments. The The first one is to make the robot capable of acting in an autonomous manner, both as an instructor and a learner of the semaphore flag signaling system. And the second one is to make the robot capable of both encoding and decoding simple sentences from natural language to the flag semaphore system. So that's all. Thank you for your kind attention. And if you have any question, please ask.
Okay, we thank Giovanni. Any question for this talk? Any question? Please, no question. Okay, we go in the next speaker. I cannot do question as a co-author. So the next speaker is Eduardo. He will present to us a novel big data analytics approach for detecting cyber attacks. Please go ahead.
Yeah, thank you. Can you hear me, first of all? Can you hear me?
Yes,
Okay.
yes.
Okay, thanks. So I will share the screen. Okay, can you see my screen? Going back to the first slide. Yeah.
Yes.
Okay. So thanks Alfredo for the presentation. So I'm presenting this work that basically deals with computer security, and in particular with distributed denial of service. So this kind of attack is quite common and is one of the main way to, let's say, to destroy some node in a network. Basically, it is done by several different connections that load too much a server that then is not able to answer to all those requests, and then it is shut down. So this is quite a famous kind of attack. The first type of this attack has been recorded in 1996. The victim was Penix, a particular company. And then the most recent and important case of this kind of attack comes from June 2019, where during the Hong Kong protest for the kind of law change with China, the Telegram app was subject to such kind of attack, and so was shut down. And finally, in September 6-7 of 2019, Wikipedia was a victim of that kind of attack. So what are the main effective features that can be applied in order to solve this kind of problem? Well, the most effective basically estimate the normal user behavior, and during an unpredicted amount of traffic, then the access to the website or to the web services are just enabled for those IP that were usually recorded before the attack. So what we are going to do is to take this kind of approach and insert some system identification techniques. In particular, we consider Amnestyle model and Volterra kernel. So system identification, as you know, is a branch of control theory that basically uses statistical methods in order to describe dynamical systems. The main approaches are three, so white boxes, in which we already have a physical description of the phenomenon, like, for example, the Newton law. But as you can imagine, this kind of setting is not applicable for the estimation of IP access and functionalities. Gray box, so we have a general model with a set of parameters, or black box where we do not have prior knowledge. all those two models belongs to the class of gray boxes. So we have an underlying mathematical structure that we optimize by minimizing the error and by providing the optimal values of some parameter of those models. So how we can apply system identification to our problem? Well, we define Sn to be the vector containing the distribution of the IP address and the number of requests that they did. So we suppose to have an estimation. So this Sn8, that is the number of requests from a particular IP, to be a function of the same distribution in the previous time step. Okay, of course, we consider F to be time invariant, finite memories, continuous and non-linear prediction, in particular time invariant because we consider that the prediction depends just on the previous values. So the distribution that we have observed in the previous time step. Finite memory, because of course we consider that the system has a memory that is not infinite. Well, continuous basically because it's a good property to deal with, at least in the first study. So what are the two models that we considered? The Volterra series that basically weight all the previous observations, as you can see in the first formula. So we are considering weighting the sum of the previous observation plus a nonlinear term that is mixing the previous observation in different time lags. Instead, as you can see from the graph on the bottom part of the slide, the Amstrad system just consider the power of the previous observation. So we have that Sn8 basically is a combination through functions, through some coefficients of the previous observation to some power. So for that reason, we have non-linear models. So in order to check our methods, we consider a database that is basically the number of requests that comes to the World Cup website during 1998. So this is a huge database, and we have to admit that there are no really a lot of choices in the web in order to, let's say, have a way to test the algorithm. So if you are interested, we suggest to use that kind of database. This database contains information about the timestamp of the request, the client ID, that is basically an anonymization of the IP that request information from the website of the World Cup. Object ID are detailed about the request, size the same method. So we have some REST requests like GET, POST, etc. The status is related to the status of the request, so if the request went wrong or not. And type and server are just other information that are related to the organization of the server. So what we find is that one. So this is the representation of the error of the Volterra series with respect to the various time steps. So as you can see, the error at the beginning of the prediction error with respect to the real distribution of IP is quite big in the first day, because of course the system has to collect enough data to provide a reasonable forecast. Then it more or less go down until the, let's say, May 15, where there is some increase in the error. This is basically due to the fact that in those dates World Cup start. So of course we have a sudden increase of different EP that were considering to access the website. So this of course increase our error. Then when we reach the peak of EP access, this kind of error go down basically below the 10% that is a reasonable estimation. In this final slide, we compare several type of let's say, policy that can be applied. In particular, we consider the MS-Cray model, the Volterra kernel, and sequence clustering. Those two models were the one that we propose in the article, while the sequence clustering is another standard technique that is used. In particular, since we know that all those methods are quite computational intensive with respect to the application, because if you imagine we have to provide access or deny the access to EP in a really short amount of time, dealing with the information that we already have. So one possibility is to, let's say, stress the model by considering less information with respect to the amount of information that we have. So basically here you can see how the performance of the methods varies with respect to different amount of EP of information, so EP data that we consider. So of course, if we consider near to zero information, so we are in the left part of the graph, we will see a lot of error. Then
okay, we need to conclude. To conclude.
Okay, then if the amount of EP is larger, of course, the error decrease. And just last final observation is that by the comparison, we can state that we can use the Amsterdam model, use just 40% of the data and achieve good results. So thanks for the attention.
Okay, we thank the speaker. Any question? Any question? Any question? No, there is no question. Again, I can't do as a co-author. So I want to thank you, everyone, and
Thanks
please enjoy the rest of the conference online mode. Bye.
Thank you. Bye.
Thank you.
Bye.
Thank you. Bye.
Goodbye.
Thank you. Bye.
Okay, guys, can you hear me, first of all?
Yes, I can.
Okay.
Yeah. Yes.
Okay, perfect. So, is there already some presenter? And in particular, the one of the first group? Or we just have audience?
Are you the chair?
Yeah, yeah.
Okay. I am the assistant.
Okay, thanks. Okay, so we just have audience until now.
I think so.
Yeah. Yeah, so let's wait some more minutes.
Yeah.
So it seems that no presenter is there.
I'm here, Jefferson Moraes.
I'm also here, Milos Ajkovic.
Okay. So for the which paper is yours?
My paper, it's the big data variational Bayesian framework for supporting the prediction of functional outcomes in wake-up stroke patient. That is scheduled on 12 o'clock.
Okay, perfect. And the other speaker were the one of which paper?
So my paper is improving the clustering algorithm automatic generation process.
Okay, so we also have the presenter of the other two papers.
I'm here, and my paper is Latin-wise generating for few short learning use information story. I'm the second one.
Okay. So yeah, I think that well, we can start. But previous to that, well, I just ask you to take into account the time. Okay, so please be in the 8 minutes. So we leave some more minutes to questions, and well, yeah, that's my only suggestion. Okay, so well, welcome to this section. I let the floor to the first talker that will talk to us with respect to the paper, A Big Data Variation Bayesian Framework for Supporting the Prediction of Functional Outcomes in Wake-Up Stroke Patients. So, thanks.
Okay, let me just share my screen. Okay. Can you confirm that you see the screen and the presentation?
Yeah, I see the screen and the presentation.
Okay, thank you very much. Good afternoon again to everyone. I'm Milos Ajkovic. I'm Senior Research Associate of Biomedical Engineering Group from Department of Engineering and Architecture of University of Trieste in Italy. I will report our results about the study of big data variational Bayesian framework for supporting the prediction of functional outcome in wake-up stroke patients, as the chair stated. The study was conducted in collaboration between our group and the neurology clinic of Trieste University Hospital, a radiology unit of Trieste University Hospital, and IDEA Lab from University of Calabria. We are talking about stroke, the prediction of stroke outcome, and despite the recent progress in treatment and prevention, stroke is still one of the leading causes of disability and death among the elderly population worldwide. Among the stroke patients, wake-up stroke, the stroke at awakening represents around a quarter of acute ischemic stroke events. It is important part of the stroke patients. The recent trials and studies reported that reperfusion treatments in safe and efficacious in wake-up stroke patients, especially in those selected by perfusional neuroimaging, so also the perfusional neuroimaging features has to be considered. To select the patients who can most benefit for the treatment and to guide the treatment and rehabilitation strategies, the early prognosis is of paramount importance and is also to improve the functional outcome. The functional outcome in stroke patients is commonly evaluated in modified ranking scale ranging from 0 to 6. 0, no disability. 5, high disability. 6, deaf. So it's commonly used in clinics to retain the good outcome, ranking scale minor or equal to 2. So we can define as such a good outcome. Various clinical, demographic, and neuroimaging prognostic parameters and markers such as age, clinical severity, admission, infarct size, and so on, were associated with the good functional outcome or bad functional outcome. Nevertheless, the prediction of the post-stroke outcome is still challenging since there is a large interpatient variability. There is a substantial increase of health-related data, and significant progress has been made in technologies to analyze and understate the health-related data. This is highly correlated with the emerging big data context and to increasing focus of the definition of big data analytics methodologies. In recent years, there is a growing interest on the role of big data and machine learning in healthcare and stroke, as well as on markers and models to predict functional outcome. However, in the modeling phase, a high number of predictive features can lead to overfitting. To overcome this problem, the use of technique like variational bias automatic relevance determination, which eliminates the relevant features, is preferable. This approach has an advantage over some regularization methods which require a separate validation to prune less relevant features, and furthermore, this method produces a posterior distribution, allowing us to build a wearing-intercept sparse feature models. Therefore, objective of our study was to evaluate the possibility to predict a good functional outcome in thrombolysis-treated wake-up stroke patient by this technique using clinical, demographic, and neuroimaging features collected and extracted by data, signal, and image processing at admission. Therefore, we enrolled 55 thrombolysis-treated patients, and we extracted by gathering from clinical records, by signal and image processing. We extracted 27 most relevant demographic, clinical, neuroimaging features, those reported as the most important by the literature, and considered them as a starting feature model. We use the aforementioned variational Bayesian logistic regression to produce a sparse model. We properly processed the data before the analysis, and each variable was normalized by subtracting the mean from each variable and then divided by its standard deviation. The ability of produced model to predict accurately outcome was validated with 10 times 5 crossfold validation. Regarding the results, this technique produced a sparse feature model with 7 significant features, and in the table we report the posterior means, and there's the coefficients of the model and of the selected model features. The overall accuracy of the model was 71%. In conclusion, in this preliminary study, we assessed the possibility to model the prognosis in thrombolysis-treated wake-up stroke patients by using variational Bayesian logistic regression with automatic relevance determination, and the identified features were related to neurological deficit as NIHSS, history of diabetes, so the patients with diabetes has higher risk of the wake-up stroke, together with amount of necrotic tissue extracted for the direct CT scan as an aspect ratio, and CTP core extracted by CT perfusion imaging processing. Those identified features were able to predict outcome with moderately high accuracy. The future work should be mainly oriented to improve the actual framework, also including a larger data set. Thank you for your attention. And if you have any questions, I am here. If you have any questions later on, you can also write me on the email reported in the last slide.
Okay. Thanks a lot, Milos. So, well, is there any question? Okay, so I have one related to the future work. So, did you plan? What did you plan about the future work? I mean, you plan to do it with the partners that you told about in the starting part of your presentation, or just to make research without them? So I am a little bit curious about that.
Okay, we plan to enlarge the study, involving also the other partners which was involved in this preliminary study, of course, to enlarge the data set, maybe also to enlarge the number of features from neuroimaging part, maybe considered some other neuroimaging features deriving from the perfusional neuroimaging. Also, maybe consider to enlarge with some centers which have MRI imaging, but these are the future plans. Okay. Also, to work on the to improve the framework.
Okay. So thanks a lot. So thanks again for your presentation. And well, I will leave the floor to the presenter of latent weights generating for few shots learning using information theory. Thanks. Okay, we can share the screen. We can see your screen. Yeah.
Okay. Hello everyone. I'm Zongyang Li from Sydney University, and our paper is latent weights generating for future learning use information theory. Here is the outline. Deep learning methods achieve great success in domains such as computer vision, natural language processing. However, their hunger for larger amount of labeled data limits the application scenarios, where only a few data are available for training. As shown in this figure, from AlexNet to AlphaGo 0, it's a 3,100 increase in computer. But do we have enough data for this task? For a cat classification task, we have to collect so many data, and with a lot of data training. And we face 4 different tasks. We need more data for this task and more training. It's not effective and scalable. For humans, in contrast, we are able to learn from limited data, which is desirable for deep learning methods. Humans are quick learners. We can learn to classify different animals just with fewer images in a little baby. Future learning is thus purposed to enable deep models to learn from very few symbols. Mid-learning is by far the most popular and promising approach for future problems. And mid-learning is a learning to learn method from dataset to datasets. As shown in this figure, in training phase, which is called mid-training, the training dataset which only have future data for the modern to fast learning, which overcome the problem we mentioned above. Optimization-based mid-learning, such as modern agnostic mid-learning, learned a good initialization while gradient decide method, which trains the model's initial parameters for the best adaptation without placing constraints on the model architecture. And MAML is an end-to-end learning model, which combines training and testing stages in one model. And as shown in this figure, in the mid-testing phase, the training data will fine-tune the innate model to adapt model. In this way, optimization-based meta-learning can learn a good initialization while gradient descent method. However, previous works only considered a first initialization weights for different samples, which may be suboptimal due to the few short challenger, and it is difficult to guarantee the exact and universal weights for all the diverse core samples from very few training samples. To address this problem, we propose latent weights generating using information theory for few short learning in this week. Exciting weights generation method generates the classification weights conditioned on the support side only, which is equivalent to using extension pace. However, the classification weights generated in this way might be suboptimal. This is because estimate the exact and universal classification weights from very few labeled data in this support set is difficult and sometimes is impossible. The generated weights are usually in lack of adaptation to different query samples. The encoding process includes two pieces, namely the contextual piece and the attentive piece. In the attentive piece, a new multi-hand self-attention network on the support side is employed to encode the global text information, where multi-hand attention is claimed to be able to learn more presentation from different subspaces. Outputs of self-attention in attentive piece plays the role of providing the value context for different core samples to attend the following across attention. In attention network, the individual query sample attend to the text context, and then it is used to generate the classification weights. Therefore, the classification weights are adaptive to different query samples and aware of the text context as well. However, sharing the same self-attention networks might limit the expressiveness of learning representations in both pieces. To achieve this, we use contextual piece to learn the representations for only the support set. With more information of task, we can have a better representation. As shown in this figure, we can combine XCP and XAP as input of weight generate, which can be interpreted that each query sample has its own latent representations for support side to generation special classification weights, which are both aware of the text context and adaptive the divided query sample. Besides the weight generate G, we have another two decoders. They both take the generate weights W as inputs and learn to reconstruct X respectively. Since the classification weights W generated from G are encoded from attentive piece and extension piece, it is expected that we directly have query special weights. However, the information from attentive piece is not kept well during the weights generation. To overcome this limitation, we propose the maximize the mutual information between generated with and support as well as query data. And the loss function to train the network can be written as shown in this figure. Evaluate our purpose method. We use two commonly used benchmark datasets, mini ImagerNet and tiered ImagerNet. As shown in this figure, for tiered ImagerNet, the split nearest routing of ImageNet result more challenging. It let's take region with test classifier that are less similar to the training classes to compare with other methods and analyze our model. We use this image feature similar to REO. And here is our experiment. We compared the performance of our approach, RWGIT, on two datasets with several state-of-the-art methods proposed in recent years. In the top half parts of Table 1 and 2 displayed the method belonging with different meta-learning categories, such as meta-based, gradient-based. The bottom part shows the classification with generation operating, including domestic prediction, REO, and RWGIT. And the table 3, we perform details analysis on RWGT. It shows in table 3. Here is our conclusion. In this paper, we introduce Latin with generating user information theory for few-shot learning, and it learned to generate optimal classification weights for each query sample within the text by two encoding paths. To guarantee this, the lower bound of mutual information between generated weights and query support data is maximized, and the effectiveness of RWGIT is demand studied by state-of-art performance on two benchmark datasets. That's all. Thank you very much.
Okay, thank you a lot for your presentation. So, is there any question? No question? Okay, so I just have a really fast question. So, what about future studies?
For future work, our team think there's still some trick and technology can make more performance in the RWGIT, and with okay, thank you.
Okay. Okay. So thanks again for your presentation. So I will let the floor to the presenter of the paper, Improving the Clustering Algorithms Automatic Generation Process with Cluster Quality Indexes. Thanks.
Okay. Thank you for the introduction. I will screen my. So there's some moments. Share my screen. Share. Everyone, can everyone see my screen? Okay. Okay. Let's start. Hello, everyone. My name is Jefferson Moraes. I am professor at Federal University of Pará, Brazil. I will present the paper Improving the Clustering Algorithm Automatic Generation Process with Cluster Quality Index. This presentation is divided in three parts. First, I will present the introduction, and I will give some feedbacks about out-clustering tool and goals of the work. Second, I will present the methodology of the work and dataset used. Finally, I will present the experimental results, conclusion, and future work. As you know, clustering is one of the main techniques of data mining. So there are many clustering algorithms in the literature, and selecting the most appropriate algorithm for a given dataset is not a trivial task. However, there are some initiatives based in evolutionary algorithm for this test, like mock multi-objective clustering with automatic K determination, mock multi-objective clustering ensemble algorithm, hybrid selection strategy, and out-clustering focus of this work. Out-clustering is based on evolutionary algorithm called the estimation of distribution algorithm, EDA, and a direct acyclic graph has an ancillary data structure to generate the clustering algorithm. Here we have the graph where the nodes of this graph represent the main procedures of a density-based clustering algorithm implemented in the literature. These procedures we call building blocks, and these edges of this graph are the connections between these procedures, considering its inputs and output parameters. To improve the confidence results presented by out-clustering, two solutions are possible. First, we can apply quality metrics of cluster formed by candidate solutions. Second, we can use ensemble classifiers. The use of ensemble classifiers is computational expensive and therefore was not considered in this work. In this context, the proposal in this work is to include in the evaluation process called class of out-cluster a cluster quality metrics. We use three quality metrics: Dunn, Siller, and Davis bound. So here we have the general scheme of the proposed approach for calculate fitness in out-clustering, considering clustered quality metrics. The approach in green, the class method in blue, highlight in blue, it was implemented in the class method in out-cluster. In green, you have the proposed approach. First, we extract the cluster using the test dataset. Second, we evaluate the cluster, use the quality index, and after that, we apply a normalization technique. And finally, we calculate the individual's final fitness for a simple average between the normalized values of the class and the evaluation metrics. It's important here to note that any other metrics for cluster evaluate can be added in the proposed approach. So these results in this work is baseline results for other works. Here we have the experimental setup. We use 4 datasets, 3 from UCI data repository and 1 artificial generated. Here we describe the configuration of each dataset. Also, for each dataset, we run the out-clustering 10 times, considering 500 generations per hour and a population with 50 individuals. The class attribute, when existing, was eliminated from the datasets. In other words, it's not considered in the experiments. Okay. Here we have the first result that we want to highlight in this presentation. In this picture, we have a alluvial graph of the behavior of the out-clustering probability model, considering BUPA dataset, 500 generation in 1 round. Analyze the graph, we can see that out-clustering without the proposed approach, generated a good diversity of algorithms, which are generated with a maximum of 2 building blocks. You can see here in red 2 building blocks, one algorithm with 2 building blocks, and one algorithm of one building block. On the other hand, when we considering the proposed approach in the autocluster, the proposed approach increased the diversity of algorithms. We have more algorithms generated, and some of them are composed with 3 building blocks. Okay? So the proposed generate more algorithms and generate algorithms with more than 2 building blocks. Here we have another important result. In this figure or this picture, we can see the fitness average of the individual with non-zero fitness for each generation. In this case, we consider all rounds to avoid eventual bias. It's possible to see in this picture that the average fitness of the proposal was higher of the traditional clustering, autoclustering method, is higher than for all datasets. As final result to be highlighted, we have in this picture a fitness box plot of the proposed approach in traditional autoclustering, considering individuals with fitness greater than 0 from the last generation of each round, round 1, round 2, and so on. Analyzing this result, we can see that 40% of the results using the proposal that contributed to high average of the fitness. For instance, for rounds 5, 9, and 10, the proposal shows good results with average fitness higher than traditional autocluster. As conclusion, this work proposed a new model for evaluating the selecting of individuals in autoclustering tool. This selecting process was calculated by adaptive class method and clustering quality index have been added to compose a new quality cluster metric. The results showed that the approach was promising because it's allowing increasing the diversity and quality of individuals in each generation of the evolutionary algorithm. For future works, we suggest evaluate other clustering quality index, evaluate other classifier together with or replace the class method, to investigate the impact when considering the only one of cluster quality index, and finally evaluate other different profiled datasets. Thank you very much.
Okay, thanks to you. Is there any question?
Rafael here. I have a question for Jefferson.
Yeah.
Okay.
How about the performance? You have to
Yes.
run the clustering several different times. Do you have any way to try to evaluate the performance, the runtime of the algorithm before running it?
Yes, a good question. We measure the performance and see that, for example, for one round, the autoclustering performance run in, let's forget, in 2 days. 2 days for run autoclustering for one dataset, for example. Because the autoclustering combine many building blocks. It's a evolutionary algorithm, and so you have to try to see the performance. So the performance is not explicit in the paper, but we run the autoclustering in 2 days approximately for one data set for one round, for example.
Okay, thank you.
Thank you.
Okay, any other question from the audience? Okay, so I have one. During the evolution of your population, do you use something like generation in which you delete almost all the population, or you just use the, let's say, standard way to destroy individuals? Can you hear me? Okay, can you hear me?
Yes.
Okay. Okay, so maybe the presenter has some problems. So I think that we can continue with our presentation. So adversarial deep Tucker decomposition for multi-criteria recommender systems. Is there the presenter of the last paper of this section?
I think he's not here.
No, me too. So, Federico, what we are going to do? We just stop the section right there.
If everyone has done with his presentation and there are no any questions, I think so. It's time to close this session.
Yeah, I think so.
Okay, thank you very
much.
Okay. Thank you all for attending.
Bye-bye. Thank you.
Enjoy the conference. Bye.
Thank you.
Bye-bye, everyone.
Bye-bye.
Streaming is on.
Test. Test.
Hello, everyone.
Hello, everyone.
Hello, still 2 minutes to go. We have 4 papers this section. I didn't see the first presenters yet. Alessandra is here, and Mohammed Sbai is on the room.
Mohammed, I think he's coming because I heard from him on.
Hello, still 2 minutes to go. We have
Rafael,
okay, go ahead. I didn't see the first presenters yet. Alessandra is here.
Rafael.
Yes.
I heard Mohammed, the guy who has the 2 other papers at the end of the session on Riot, and he told me that he's coming. So,
Okay.
I mean, he should be fine.
Yes, I'm here.
Yeah, the first one, I think, can't be here with us because in the last session it was absent.
That Yue Zhang.
Yeah.
But maybe he
Okay.
will show up. Maybe he will show up. Who knows?
Yeah.
What we can do, if it's okay with you, what we can do is start with Alessandra's presentation.
Yeah.
And then see the order of the others.
Yes, but let's wait 5 minutes more. What do you say? A couple of minutes more if someone comes, just in case.
We have time.
Yeah,
okay,
we have
Alessandra, you'll be here in 5 minutes. We'll start with 5 minutes.
Okay.
Yes, it was me on YouTube. I was having Raphael. I was having YouTube opened, and it went through microphone. There is a little delay between YouTube and the room, so you were hearing yourself twice. Yes, I was. It was my fault. Sorry.
Okay, no problem.
So what is it now? 8 o'clock in the morning in Brazil, right?
8 in the morning.
I'm sorry you had to wake up early.
No, I'm used to that. That's no issue. But I have 2 kids that they also having lessons through online and video, so I have to get everything ready by 7. So 7 o'clock is a hard time for me. But I usually wake up at 5:30.
Yeah, shouldn't be a problem. Yes, okay.
I think we can start.
Yes.
Okay. So, folks, good afternoon in Italy. Good morning from Brazil. I'm Rafael Santos. I'm going to be the chair of the session GenTrack 514. We are supposed to have 4 papers here, but the first author didn't show yet. So I'm going to go ahead and skip to the second paper. That's Dynamic Community Detection into Analyzing of Wildfire Events from Alessandro Gouveia, Didier Vega, Moshe Catalaca, Leonardo Ferreira, Albert Macau, and Marcos Quiles. And I understand that Alessandro is going to present. So Alessandro, go ahead. You have 8 minutes for presentation, but a little bit more if you need it.
Okay, everybody see my screen?
Yes.
Okay, so hi everybody. Well, that's our agenda, but let's just save some time and go to the next slide. First of all, to start, I need to keep in mind that network science can be described as a set of tools to support the study of complex systems. Wildfire, in turn, is an environmental process with a relevant impact on human life. So modeling it is a task of interest for science and decision makers. And although it is a complex system, as far as we know, few works have been modeled wildfires through networks. In addition, we need to know that fire data are usually available in the form of spatial temporal events. Such kind of data is usually modeled by functional networks. This approach has its advantage, challenge, and its issues involved, but let's talk about the way we choose to model our data. So chronological network is an approach proposed recently. In this model, we divide the geographic area into grid cells. Each grid cell will be mapped to a node on the graph, and that will be constructed through a process that consists of linking 2 nodes if a consecutive event occur between the cells. I mean, imagine that a fire event was detected to cell ID A, and after that it was detected in cell ID B. Independent of the elapsed time between these 2 detections, we will create an edge link the node A to node B. So some works have used this model to study wildfires. However, our work differs from them in many aspects. First, our objective is different. We explore temporal information to identify where and when a fire events occur. I mean to determine the period in which events are expected and where they are expected. And to do it, we investigate the use of community detection structures to reveal wildfire dynamics. So why we use dynamic community structure to do it? Well, a community may be described as being a set of vertices more likely to share edges. This kind of structure that's able to capture change in the network. Well, any significant change in the network will produce events in the community life cycle. I mean, a given change on nodes and edges may produce a birth of a community or the split, marriage, death, and so on. About your data, we have 15 years of wildfire evidence from Amazon Basin. Such data are provided by Vega in the form of snapshot, and it is available for everyone. And let's go to the next slide for more details. Here, we have an example of Vega snapshot, and please note that Vega uses a grid division of 30 to 30. It holds events that occurred in the timeline of 7 days. So observe that the snapshot is a graph formed by 900 nodes, where where edges are linked according to chronological network model that we described before. So on left, I show all snapshots for a given year, and here we could spend some time talking about this figure. But for now, just observe that there seems to be a pattern in the dynamics of wildfires in Amazon basin. There are good amount of ways to detect community and analyze its life cycle, but well, our work may be seen as a pilot. So our concern here was just to select the simplest and well-known method. So for this reason, we choose Blondel to detect community. And here, I need to emphasize that Blondel detects the community in each snapshot in an independent way. So it is not doesn't have any aspect of the community life cycles. Then to detect it, we used the approach proposed by Sun. However, in some methodology, when a community dies, and here I mean when it is not detected anymore in a given snapshot, it will never be how can I say it, labeled again with the same ID. So even though the community appears again, it will be considered a new community. And for our analysis, the resurgent is crucial because it is signed to a temporal periodicity of a given community. So we use the Jakarta index to do a peer comparison. When we talk about community detection, we need to some measure to tell us how trustful are the structures we detected. So one of the most famous quality measures in the literature is modularity. And in the figure on the top left, we show using colors the value of modularity in its snapshot. Observe that init square represents a snapshot, and we organize it by weeks and year and an attempt to see some temporal pattern. It is not so clear, but with some effort, we can know that there seems to be a period where we can find the barrier score. Please look, for example, the modularity found from week 40 to 50. However, we observed that chronological networks did not foment the detection of resurgent communities. We need to set the threshold of 70% to the Jakarta index to detect only 2 communities. The figure on the top left shows their behavioral pattern. Here, the color indicates in which snapshot the community was detected and the size of its communities. So we post-process the VEG snapshots to impose some restriction on the location of the events. We did it cutting the ads that connect distance verts on grids, and this process broke the network in a set of components. Through this new set, we got a higher value of modularity in most of our snapshots. It was expected because now we have a set of disjoint components. The new set was able to reveal many resurgent communities, and each detected community seems to belong to one of these patterns. I mean, communities that may occur in any moment of the year, and a set of communities which occur from some seasonal pattern. However, we know that all communities were composed by few vertices, and here, when I say few, I mean 2 or 4. Let me use a simple example to illustrate what we observed in the set of communities. First, observing communities from the same snapshot, we found structures that are close geographically, which were classified as 2 different communities. And second, analyzing the sequence of snapshots, we observed that silly changes between the vertices that compose them were enough to label these communities as being different structures. So we changed the way we compute the matching between communities from, may I say, simple Jakarta to weighted Jakarta. Then we found 23 communities that follow one of the patterns mentioned before. So in little words, we can conclude that it is possible to model fire dynamics through networks, mainly using dynamic community. And we claim that the evolution of the network is able to tell us where and when a fire events occurred, as well as determine the regions and periods where such events are expected. However, I need to mention that we do not have sufficient evidence that to relate a given geographical region with one of the fire patterns. I mean, given a geographic area, I can tell which kind of fire behavior is expected on there. Therefore, your futures works will be done in this sense. So thank you. That's it. Questions, suggestions?
Thank you, Alessandra. We are open for questions.
Okay.
Rafael, I raised a hand. Alessandra, hello. I can see you finally. Something's okay. Hi. Sorry, I have problems with webcam. I can't see myself. Anyways, can you hear me?
Yes.
Yes. So my question is more general, since you are kind of combining this community analysis and wildfire. So I'm asking you not specifically about your data, but a kind of a more general idea, which interests me a lot. Which is, do you see any kind of? Would you say there is any kind of patterns between the nature of local communities? In terms of, I don't know, internal cohesion or ethnic differences, or I don't know, even and the capability of those communities to signal the fire and strike it down earlier. I mean, is there any relationship that you think would be is relevant in this point? I don't know if you got my question.
Not really. May you ask me again?
Yes, let me try to an example. So basically, you're showing us that all these fires are happening in different places around Amazon. Okay, and these fires are, of course, sometimes in the middle of communities, in the middle of local communities of people who are living there and using in that space, even indigenous people, I suppose. So is there, would you say there is any link between the nature of features, characteristics of those local communities and the capability to detect and stop outbreaks of fire in different places? I don't know if I made myself clearer.
Well, sorry.
Okay. Maybe I can help. Ivan, actually, the community that Alessandra is researching is not a community of people, if I understand.
Yes, I know. This is that is why I was saying that. Yeah, I was just stimulated by the talk because I'm interested into the link between the social. This is I said it is not too much related to your specific work, but more in general. If you who are there in Brazil are having this kind of debate about what kind of strictly local kind of communities and their capability to give a prompt response to fires. But anyway, if you want to comment, but that doesn't matter, Rafael. I mean, I don't want to insist. It's not relevant indeed.
I can talk a bit about that because we had, I think, a research project about people getting involved in the detection and information of that. But funding was cut out 3 years ago. But what happens is that people doesn't communicate so much. What we have, most of the information we have about a forest fire is collected by an early detection system that we have a satellite-based early system detection system. So when we have fires inside the place people live, for example, farms, they just go out and they call the local fire department or the environment preservation agency, and that's that. We don't have too many communication about that. Well, between people, I mean.
Okay. Thank you, Rafael. And thank you, Alessandra, for your good presentation and great work. Thank you.
Thank you.
Okay. Do you have other questions about Alessandra's work? I'm silent. Okay, if we don't have any other questions, I'd like to invite the next presenter. Thank you, Alessandra.
Thank you. We are welcome,
Okay.
sir.
So the next presenter is Yiwei Zhang on the room. I don't see. No. So, Mr. Sbai, are you ready to present? Please turn your microphone on.
Good morning, sir.
Good morning. Good morning from Brazil. Are you ready to present?
I am from Tunisia.
Okay, so please go ahead and share your screen with the slides.
Okay.
So in order, you have 2 papers to present. The first one is towards an agent-based context management architecture. Are you going to start with that one?
You can see the presentation or no, sir?
Mohammed, can you get closer to the microphone? We don't hear you well.
Can you see my presentation or no?
No, just the screen, just the video, the webcam. Okay, now we can see it. So Mohammed, please go ahead.
I can begin now.
Yes, please go ahead.
Okay. The objective of our research work is to find a solution for management context in a district system. So we begin by the first paper titled Tools and Agents Based Context Management Architecture.
Mohammed, please speak slow. Try to speak closer to the microphone.
Okay.
Okay, it's better now.
We begin by the presentation of the first paper, Tools and Agents Based Context Management Architecture. Our plan is introduction related works, contribution, detailed architecture, evaluation, and conclusion. So first, we'll begin by the introduction. Ubiquitous computing allows good integration of computer technologies in various fields such as education, health, transport, by daily life of modern society. However, the ubiquitous environment is characterized of users. The distributed nature of this kind of environment and the mobility of the devices used, which are often of limited capacity, requires a particular context management either for its collection, representation, and its in order to respond to the problem of heterogeneity of representation, the limits of devices, and network bandwidth. The major challenge of the big physics computing is to provide users with the required service at the right time and according to their current context. One of the solutions is to be able to manage the context and to make minimum discovery of service according to the current context, which is the subject of our work. Our approach is based on interaction and cooperation between different agents who can even be mobile. And now we will present the related works. In this field, several approaches have been developed to manage the context. However, these approaches differ greatly in their architectures and implementation. They depend on the requirement of the system and the process of identifying, transforming, and processing context information. For example of the work, Zuyo proposed a context modeling approach that can dynamically manage different types and values of context. Specifically, they use ontologies to improve the meaning of users' context value and automatically identify the relationship between different context values. Based on the relationships between context value, they capture the potential service that the user might need. The objective of the work of the Zuyo is and study automatically rich, reusable, and scalable context management model based on ontology, which supports collaborative reasoning in an omnipresent multi-domain application. They propose a reusable context model based on ontology. Vario ontological approach. The proposed ontology is specific for domestic environment smart home, which helps application developers in the creation of ubiquitous home computer application. This ontology is intended to be shareable between middleware and application, so that application developers can establish rules to define the context of the application without depending on specific middleware context model. Again, my work presented an ontology-based approach to the development of context-sensitive service. The overall architecture proposed is composed by three main components: user device, context recovery and assimilation, and context processing and reasoning. And now we will make a comparative study of related works. For this, we choose the following comparison criteria: the flexibility of the context model, interpretation and reasoning of the context, separation between context management and adaptation, adequacy with limited resources. We can see in our comparative study table, for example, for the work 5, there is no flexibility of context model. And for the work 4, there is no separation between context management and adaptation. We can see also for the most latest works, there is no adequacy with limited resources. To overcome the various limitation of the approaches seen previously, we will present our context management architecture. It allows the service requester to present the context, they current context, and also allows the service provider to adapt it according to the sake of the context. Our architecture is divided into 3 levels. The first level is the context source level. The context source level plays the role of context monitor. And the second context level and the context the second context, the context level is responsible for the management and the modeling of context. And the third level is responsible for the adaptation service. So, in our context source levels, we have used 2 types of agent. Agent sources who monitor the context of several devices, and the interpreter agent collect and interpret the information from the agent center. Our context level contains a context agent. The context agent uses the change log to update the instance of context. The instance of context contains the current context of user is an instance of context model. Our application contains 2 types of agent: adapter agent and client agent. The client agent have an instance of context to consume the service. But before the adapter agent uses the change log and the context model to adapt the service to the client agent. And now we will present the interaction in our system and the internal architecture of agent. But before, we will give an illustrative example. For the description of our approach, we give an example to decide how it can be used for context management according to our approach. This example presents an ontology corresponding to a global model of the context proposed by the developer of service. This model defines the concept and relationship that changes can cause a change in service behavior. This is the example of our context. We find here the user, which uses the device and has age and name. The user is located in environment. The environment is a place. The device can be a mobile or PC. We present below the interaction protocol between the different components of the system. An interaction protocol defined by the sequence of communication acts exchanged between the agent of system. The main sequence diagram models the different interaction between agents, which are modeled in the form of actors. In our class diagram, we present the structure of our middleware. It describes the different elements and their links which are deduced essentially from the interaction diagram. The different agents in our system inherit the characteristics and the behavior of the abstract class agent. This class presents the internal and generic architecture of each agent in our system. And now we'll present our internal agent architecture. We found here the agent state, which is the current state, which is defined by each current sub-objective and the status of the implementation of each action plan. The mobility, this property defines whether the agent is mobile or not. The perception component allows the agent to visualize his environment. The analyzer is this component is used to analyze the perception information, and the reasoner makes it possible to reason about the information obtained from component analyzer. By reasoning, the agent will deduce the different action possible that correspond to his current perception and objective. Action execution of the action selected in the phase of reasoning. And now we'll present the evaluation of our approach. For example, we have Ryan uses our application by providing his purposes and launching requests from his computer. In his first request, he asked for service historic the commercial offers of mobile phone. We have here the query of the user Ryan by mobile phone. He prefers that the service returned be in English and that his source be close to his location. And the service search interface will present to this user the two results. The first result of the query don't take into account the context, and the second result taken into account the context of the user. To evaluate the result of the result, we want to throw the user the result service by service, noting either zero in the case where the service is not relevant to the user, or one in the case. Each of these two results calculated the precision of the first 5 service returned. Based on the precision calculation, next we calculated the average of the detailed for each of the two types of results. We can see here the curve, the red curve, which represents the precision of the result without context. Sorry. We can see here the red curve, which presents the precision of the result with context, is above the blue curve, which presents the precision of the query result without context. And now we will conclude our work. In Ubiquitous application, the context on components the problem of heterogeneity of representation, limitation of device capacity, and network bandwidth. In order to overcome this difficulty, special management of the context is required for its collection, updating, and exchange. For this, we propose that in this article, an agent-based context management approach. Our approach is characterized by its great flexibility, simplicity, and allows the developer of service to put his point of view concerning the context that must be used while avoiding the requirement of using unified context model. Thank you for your attention.
Thank you very much. Thank you very much, Mohammed. Do we have any questions? Any questions from Mohammed? Okay. Mohammed, I have a quick question. I noticed that you propose an architecture but then you show some screens. So do you have a reference implementation of the architecture? Implementation of the software.
Yes,
Can you see the chat?
Yes, I begin the because this work is related with the second work.
Okay, I just typed the questions in the chat. If you can take a look at that, may be easy to understand.
Sorry. Here is this an interface for my beginning of implementation.
Oh, that's right. Okay. Okay. Any more questions for Mohammed? If we don't have further questions, I'd like to thank you and ask you to present your next paper. Your next paper is Management of Context in Mobile Environment.
Yes, sir.
Yes. So please go ahead.
Okay. The second part is the management of context in mobile environment. Our plan is the introduction related works, foundation, and our prototype and conclusion. We begin by the introduction. There has been a growing interest in using context awareness as a technical design architecture dedicated to mobile environment in order to adapt and produce service according to user context. Context management in mobile environment is task for two main reasons. Firstly, supporting different devices and multiple interacting platforms is difficult. And secondly, it's difficult to achieve environmental context awareness and to proactively adapt service to dynamic changes. Addressing this issue means that systems should be capable of providing a uniform and efficient architecture for communicating the entirety of entities within the context to meet user needs and adapt to their preference. In view of this requirement, our work aims to create a modular and flexible architecture which takes the context as the first input, as the most important element for reasoning and adapting. Now we will present the related works. In recent years, many context management approaches have been developed. However, this approach differs greatly in their architecture and implementation. They depend on the requirements of the system and the process of acquiring, transforming, and processing context information. For example, the work, the music work is the most well-known autonomous platform supporting self-adaptive mobile and context-aware application. This platform can be adapted to the dynamic changes of the environment. For example, location, network connectivity. In order to satisfy the user requirements and device property, for example, battery, memory, and CPU. Another work of Dial have proposed the context management middleware to provide service dedicated to the management of the context at the semantic level of the shared domain. This work offers excellent smart service management and predefines precise deployment strategy, but disagree in the user-defined policies and did not consider the prediction of user context changes. Another interesting work is SamSocial, which define middleware for integrated online social networks and mobile sensing data streams. This middleware is based on social networks for capturing and filtering context data. It proposes a generic solution to manage and aggregate context streams for multiple remote devices. This work provides richer contextual information from online social networks and did not take into account the semantic of service and context constraints. More recently, 10 years, work has based on the context toolkit infrastructure. It supports the change of XML files, file events to an anticipated data component that can be associated to fully described situation, including time, place, and other piece of context. This word uses a translation mechanism to ensure uniform and consistent behavior for every smart object executed inside the transaction and supports only notification as an action type without multimodality aspect that can be triggered as a result of situation identification and smart event detection. And now we try to make a comparative study of the related work. The design of anti-reflection in mobile environment requires taking into account a lot of context management parameters, such as context monitor, context zone, separation between context management and adaptation. This application can be used on terminal by user in specific environment and location. In addition, this application must cope with the dynamic change of context of use to carry out activities and achieve the appropriate objectives of the use. In the view of the requirement of the mobile environment, our work is to create a modular and flexible architecture, which takes context as the first entry, as the most important element of reasoning. Adapt and provide the service in a more suitable form. Modularity is considered as a key feature to improve severability attributes such as maneuverability, portability, reusability, interoperability, and flexibility. In the case of our approach, modularity is the key to facilitating measure of the design complexity and ensure the development of the overall component. So, our proposed architecture is divided on 3 layers: sensor layer, context management layer, and application layer. The sensor layer contains all data sources that can provide information useful for the context. 3 types of sensors can be distinguished: physical sensors, virtual sensors, and logical sensors. Our context management layer contains collection model, which is responsible for the data from the various sensors on the lower layer. In order to facilitate the context within the upper model, the development of the big application requires us to collect the model all the context information with the we have the use of context which are of our context model makes the literature of mobile and complex sensitive applications are flexible to allow essentially taken into account new entities specific to field of application. So here we have our context model. We can see the user, which is the platform, and the user has an attention service The executive system provides service for user, and the executive system uses several device terminal, and he has an environment. We begin now by examining our user ontology. Generate the development of interactive application for mobile environment. The focus is on the user and his expectation. It is a user-centered approach that must take these requirements into account when designing such a system. This requirement can come in different forms, depending on the environment and its component. In our user ontology, a relationship is created between user preference, such as preference for the use of this event, and an attention towards the executive application. And the primary user logs in by defining role, and the application introduces a request to perform a task, which can be divided into several activities. The parameter will be integrated into the information adaptation chain to context of use in order to better meet the different specific needs of use. So this is our user ontology. The user has got the situation, the code situation with devices, and the code situation has intention, and also has a location located in environment. Our terminal ontology with the use of security smartphones, tablets, abilities information have become very important in the sense that can inform us about the computer resource to be used in the business environment. Present here our terminal ontology. The terminal has status, which has the profile, software profile, and the terminal user and provide service. Our home now we don't the change is configuration is not limited to changing the type of the user attention, but also to any changes in the using this application. This is essential to definition in which is aspect and user interactive devices. Relations also have services that meet his needs. We offer a model which makes it possible to manage for all questions of users and understand in use. We use student location and characteristics setting this interface with environment. If you consider a strong model for adaptation purposes,
Mohammed, time is running out. Can you please hurry up?
Adam will conclude our given of the mobile element, our proposed modular and flexible architecture, which takes context first and three as the most important element to reason, adapt and provide process in a more appropriate form. Our approach is uniform and effective in communicating all of the environmental entities in order to meet the needs of users and adapt to their preferences. Thank you.
Okay, thank you very much, Mohammed. It was a little bit hard to understand. The sound got very chopped, but I was able to read the slides. Do we have any questions for the second paper from Mohammed? No questions? Okay, if you don't have any questions, I'd like to thank you very much, Mohammed, for the presentation. And I'd like to ask again if Yiwei Zhang or Xiaoye Wang of the adversarial deep structure decomposition for multi-criteria recommended systems. I don't see any of these presenters on the room. So we don't see the presenter on the room, but I guess what we have to do is close the session because they are, I think they didn't appear in the other sessions also.
Oh, okay. Because they have changed my time of presentation and without notifying me. They reported to the
Mohammed, I really can't understand you, but can you type your comments on the chat, please? The sound is very bad.
Wait, I have a problem with keyboard.
Okay, I really can't understand you, Mohammed. We have to close the sessions.
Yeah. It's time to close the session.
Okay, and I think the other presenter, the Yiwei Zhang and Xiaozui Wang are no shows. So we have to close the session. I'd like to thank you very much and ask you guys to check the other sessions and the keynote today. That's going to be, I think, in 1 hour, right?
Excuse me?
Just ask the other people to watch the keynotes.
Hey, sorry, I can't understand.
Okay, that's never mind. Just watch the other presentations. Thank you very much.
Okay, thank you.
Thank you.
Bye-bye.
Bye.